Welcome back, YouTubers. Let's go ahead and work on our first method of solving systems of equations, which is by graphing. Now, if you look at this first system that I have here, we've got y equals 1/2 x plus 2 and y equals 2x minus 4. Two variables, x and y, two equations, tells me I have the system. Now, we also mentioned in the last video that we would look at what format the equations were in to decide on the proper method to solve. Now, if I look at this one, that is in slope-intercept form, and equation 2 is also in slope-intercept form. So, both of them in slope-intercept form tells me I'm most likely going to be graphing this problem. Now, you can do this on any style of graph. It doesn't have to be graph paper. The important thing is that, especially if you're drawing it by hand, accuracy is extremely important. So drawing by hand is going to be hard to do because you have to have exactly right angles and you have to have exactly the even spacing between all of your lines. So if you draw by hand, typically when somebody sketches, there's a little bit of variance, makes it kind of hard to do by hand or by a hand sketched graph. So graph paper or any one that your teacher can print off for you, those will usually be fine. Let's go ahead and graph these things. If you remember, it's y equals mx plus b. And short little review, to graph a line, we start off with our y-intercept, which is b. In my first case, it's 2. Starts the origin and translate up on the y-axis 2 units. The reason we went up 2 was because that was a positive 2. Go ahead and mark that dot. Then look at our slope, which is m, in this case 1/2. Now remember, m, or slope, is always rise over run. So in this case, I'm going to rise 1 and run 2. Now what I always tell my students is to always run right the first time. So I know I'm going to rise 1 and then run right 2. After I've done that, I'm going to go ahead and do the same pattern, rise 1, run 2, another time to the right, and then another time to the left, another time or two, just to make sure that I got a good line. And then take my straight edge and draw the line. Once again, accuracy matters here. Let's draw my line there. Now let's go for our second line. Y-intercept is 4, so this time it's -4. I go down on the y-axis, 1, 2, 3, 4, and plot my point. And now I have the number 2, but there's no fraction here. Well, every number is a fraction. I can always just make it over 1. So rise 2, and once again, always run right at least once. Run 2, or rise 2, run 1, and go the exact same direction back the other way. I've got several good points here, so I'm going to go ahead and connect my lines. And if you notice, my two lines intersected at this point right here. Now, if you remember back from when you first learned how to graph and what the line actually means, every single point on this line is one that satisfies this equation. So if I plug in the points 0, 2 into this equation, well, 1/2 times 0 plus 2 is equal to 2. 1/2 times 0 is 0 plus 2 equals 2. That checks out. Every single point in that line will satisfy those conditions. Every single point that lies on this line will satisfy the bottom equation. In order to solve a system, we're looking for the one unique point that makes both equations true at the same time. Well, if I chose the point again, 0, 2 right here, and plugged into my bottom equation, y equals 2 times 0 minus 4. Sorry, that y should have been a 2. And then simplify. 2 times 0 is 2, gives me 0 minus 4 is minus 4, and 2 is not equal to -4. So this one cannot be a solution to the entire system. It works for the top, but not for the bottom. We're looking for the one point that works in both equations. And I'm sure some of you might have guessed it by now. That's going to be the point that lies on both lines, or the intersection point. So the answer to this system of equations is going to be the point 1, 2, 3, 4, 1, 2, 3, 4. The point 4, 4. And again, what that means is x equals 4, y equals 4. Let's go ahead and do another example of that just to give you some practice. Let's go ahead and look at the first line, x equals 5. Now, if you remember, x equals 5 was our special case. That's not technically slope-intercept. That is a vertical line. It has an undefined slope. We go out to x equals 5, 1, 2, 3, 4, 5. And that's going to be a vertical line going through x equals 5. My next equation, negative x plus 8. Let's go to 8 on the y-axis. 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. And then my slope here is negative 1 over 1. So we go rise negative 1, which means fall 1, and run right 1. Fall 1 and run 1. And then let's go ahead and connect my dots, make the line. And the one point that makes both equations true is that point there. 1, 2, 3, 4, 5. 1, 2, 3. The point 5, 3. So if you can graph the line, or the two lines, and find the intersection point, then you're going to know what the answer is. Now, limits to this one. If the intersection were to not fall exactly on whole numbers, if it were, for example, to be 5.5, 3.5, well, it makes it kind of hard because can you pinpoint that it's exactly 3.5, or could it possibly be 3.48? Decimals make this system a little bit limited, and that's why we're going to go next into how to solve using the calculator, which will always give us perfectly exact answers.